Jeremy mentioned, my name is Dave Mexicotte. I've been with Cisco about 18 years. You're going to find someone who's been with Cisco longer when Rob gets up here. But most of my career at Cisco, I came to Cisco just after we acquired a company called Celsius, which was IP telephony. And I think back to that, before we acquired them, the very early IP telephony devices, engineers went out and touched each individual phone to get them set up. Well, that was untenable, right? So they developed what became Call Manager, which was the controller for all these thousands of devices. Then I came to work primarily in the area of wireless. Very early wireless, every single AP was touched. Now, how many of you have, is anyone in here that has 1,000 APs? Right? So Rob and I, we have a customer that has over 20,000 APs. So the scale of touching each individual device, just can't happen anymore. So we introduced the wireless controller, and we touch one device. And what DNA Center is a controller for the networking devices on your network. It is a one place to go to set this up, and it hides the complexity. I think back to the complexity that we used to look at when I first started as an engineer. I mean, we would put an oscilloscope on the line and watch bits go by, right? We don't do that anymore because software layers and things like that handle that for us now and tell us everything is going fine on there. Now, the other thing that you're going to see as you talk about this technology is just all the security elements that are put into it, right? We're moving into some scary territory here. We know that there's going to be different types of attacks in the future, attacks directly on the boxes. How do you know if the software that's on that switch is the right software? It's not something that someone has hacked. So that type of security is built into this solution as well. But you don't have to deal with it on a box-by-box basis. Another really cool thing about this new technology on the 9Ks, it is one binary image that runs across the entire 9K product line. Same one iOS download to run on your 9300, your 9400, your 9500. The other thing that we've done is we've containerized the OSs on it. And what it means is that this has been a years-long process to bring this technology out to the market. I was trying to think of the 3850. That's been out for over 5 years, I think, right? So that was our first entry into this, where we set up a device that could actually start to do this. And this DNA Center will go back and you'll get benefits from devices that are about 5 years old out of this technology. So just talking about the security aspects of it here, this is pretty much what Jeremy talked about on the segmentation side, right? The ability to really micro-segment that network. And this is very important in IoT, as Jeremy mentioned. I was thinking through, I have 6 gateways in my home that go out and independently talk to something on the internet. And every one of those gateways, when it was designed, the #1 design criteria was make it cheap. Right? There's no security on those things. And some of them, because I'm from Cisco and Rob came over and set up my network for me, they're in a DMZ, but some of them aren't in a DMZ. But I've got lighting controllers, I've got a garage door opener that's on the internet, right? A device that tells me if my water tank is leaking in the basement. All those things will probably never be updated. So the answer to that is micro-segmenting those, making sure that they can't get to any other device. The other thing is this idea of intent. So what this system will do is we'll look at what you put in your network and it will make an initial decision on it saying, well, that looks like a security camera or that looks like a thermostat. So I will give it the policies that should have, and then I will allow you to investigate that and make sure that it's in the right area. And this is because our facilities guys, right? We might standardize on Honeywell, for example, but all of a sudden they switch over to Rockwell. And they're not going to tell you that, right? But we need to make sure when they plug those things into the network, they go into the right place. And there's some underlining technologies. Jeremy mentioned that we're getting a lot of new applications that come out. There's underlining technologies there that will actually allow us to place those things into the right place of the network. So a whole bunch of security here, the fact that we will put devices into the right place into the network, the fact that the switches themselves will authenticate themselves to the network and will actually authenticate the software load that's on the switch, and the ability to do all this rapid type containment. To do the rapid containment, one of the technologies we used is something called encrypted threat analytics. Has anyone heard of this? You guys have been the politest crowd we've had. They were throwing bread at us in South Bend, right? But it might be a statement that the bread is better here. But encrypted threat analytics is something that we've spent a lot of time on. We've written some scientific papers on this, and you can actually take a look. What we discovered, well, first of all, what we knew was that more and more traffic is encrypted on our network. It's encrypted from the endpoint all the way to out onto the internet. And our traditional intrusion protection mechanisms can't really see what's going on in that traffic. Now, we could put a giant firewall that acts as a proxy, and it sets up the SSL session from this guy to the firewall and then to the firewall out. But do you really want to be inspecting people's Facebook traffic and kind of get into the middle of all of that? No, we don't. What we need is a mechanism where we can identify bad actors in encrypted traffic. And we can actually do that. And we filed several patents on this. And it's an amazing technology. What we end up doing is we look at every aspect of this traffic going out, and based on what we call the metadata of that traffic, and I'll get into more about that metadata is, we can identify it if it's malware with 99.99% accuracy. It's just an absolutely amazing technology. And none of this is ever encrypted. To give you a better idea of how we do this, the first thing that we look at is the initial data packet on it, which is not encrypted, and there's a lot of information that we get out of that that we can attach, and this is like a signature based. We can attach that to malware that we have seen. But you know something, this is not the most important thing that we're looking at. If this ever went away, we still have ways that we can identify that. The most important characteristic is something that we call split, sequence of packet links and times, but it is the actual shape of that traffic. That's a pretty amazing thing, right? We look at that shape of that traffic, and we can actually use that to determine if this is malware. Now, what this solution does is it looks at this, and it actually communicates back to Cisco, that organization that Jeremy mentioned, Cisco Talos. Have any of you guys ever heard of Cisco Talos before? I recommend that you go look that up and listen to their podcasts. They do an excellent podcast on security. It makes you sound really smart when you start regurgitating what they tell you there. But it's a huge organization, and it looks at 7 times the traffic Google does every day. It's just an unbelievable organization. And this is a big data problem, right? So what do you need to do big data? You need big data, right? So that Talos data set is one of the largest data sets on malware on the internet anywhere. The other thing Talos keeps in mind is where is that traffic going? It sees those packets on your network, and it can tell where it's going in the world, and it has a traffic map of where bad malware is. And it's really cool to watch this stuff in action. You know, sometimes we'll be browsing within Cisco, and a portion of a page will get blocked because that page, which was probably a legitimate organization that we were going to, had somewhere linked to a place that had malware or bad things on it, and it automatically gets blocked. This was very effective in our early tests on this when we saw WannaCry come out. So we had this in early field trials when WannaCry first came out, and the communication went back to the firewall once we knew what was going on, and actually automatically blocked those ports that WannaCry needed to be able to propagate. So this link of the ability to see something bad happening, determine that it's bad, and take action is built into this DNA center. And you have the ability to step in front of that if you want to, right? But we're trying to automate these tasks because these things happen so fast, we want to be able to stop them as fast as we possibly can. Any questions or comments on that? Kind of pretty cool. Now, to be able to do this, what we need is ICE in your environment, and of course, we need a 9K or a router that will support this. This requires a different form of net flow to be able to do this. But if you don't want to replace all your edge switches, right, we can come up with strategies to get this into your network. And it uses something called Stealthwatch, a company that we acquired, and communicates back out to another machine language engine that we have set up on the internet. It sends anonymized traffic to it, and that's how we determine if this is malware or not. So it's a whole linked system put together that will actually identify over 99.9% of the bad traffic out there. So the cognitive analytics, this is another company that we acquired that sits at the head end and communicates back to Cisco Talos to make sure that your traffic is secure. And this is just a look at what the dashboard looks like as well, telling you what's going on in your network. Now, one other thing that you can get out of this, not just protecting it, but a lot of us get questions on, are we cryptographically compliant? Some of you work in industries where you actually have to meet certain standards. This will actually test the cryptographic compliance on your network as well, and you can use this as certifying and use this with people that are reviewing your network. All right, let's talk a little bit about assurance here. So all these things that we talked about were things that you have to put into your network, right? You have to get a few 9Ks in there. We realize that not all of you are just going to say, hey, I'm going to replace my entire access layer. So we have strategies to introduce this technology in. If you have 3850s, you've been buying them for this past 5 years, you can get benefit out of that. But assurance is something that you can get a benefit from without even changing your switch infrastructure. So assurance is a way of ensuring that the network is running the way you want it to. And you get some more benefits if you do the software-defined access. I don't want to belittle that. It's very, very important. But all these things you get on a traditional network as well. So we can start digging into what happened. As Jeremy mentioned, 43% of the time is spent on troubleshooting. And the reason for that is there are so many steps where something can go wrong. So Rob and I are on the access layer. A big part of it is wireless with universities. And when something goes wrong, when someone can't get Netflix, you know what they say the problem is? It's the Wi-Fi, right? It's always the Wi-Fi. So what this technology allows us to do is actually defend the network as well and actually find out where something happened. We had a very large university. They had an outage. They were screaming that the Wi-Fi is out. We do all hands on deck. We spend 2 days, and we find out the problem is someone had gone in and fat-fingered a switch in front of their DHCP server. Had nothing to do with Cisco, had nothing to do with the Wi-Fi, right? But how do you track that type of issue down? Well, what we do with DNA is all these devices, from the onboarding stage to, just performance, compliance, are constantly communicating up to DNA Center. There are new protocols, telemetry protocols that we've introduced with this. It's not SNMP, that's too slow for this. And they send up the metadata to this center, and we actually store it, and then we do correlations amongst it. And right now we store 2 weeks of data, and I'll show you why that's important in a moment, and we can actually correlate and go back in time on that. So all these different types of things, down to on the right type of device, we'll know the client firmware. And we can actually, what we do is we communicate back with another huge data set that we have called Cisco TAC. Has anyone used TAC in their life? Right? We actually communicate back to that database, and we will actually correlate that and then come up with a projected solution to these issues here. And I'm going to show you that even down to the client firmware side, we can actually see this information and make a decision on it. So right now we're pulling over 100 different points. When you guys get this slide, you can actually look through this. These are just some of the many things that we pull into a data set up to DNA Center, and we analyze and correlate against to actually help identify problems. The challenge is, as I mentioned most of this, it's hard to isolate things with the network, right? We allow you to quickly do that. Probably the biggest one is just the amount of data. Right, we all know how to trace something through a network, but that's a lot of command line. That's a lot of tables that you're looking at to try to figure that out. We correlate this for you automatically. And then all these other ones here that you'll actually see as you look through the slides here, the ability to pull this information up so it's a little easier to deal with. This is the guided remediation aspect of it, and Rob's going to show you a little about this when we do the demo here. But we'll actually will have solutions suggested based on what we have seen, and this data constantly changes because this is a machine learning thing. So when an issue gets identified, maybe there was a bug or something that starts hitting you, TAC will know and will start pushing down these things. So our goal is to eliminate that first phone call to TAC. DNA Center will actually have that information loaded based on what it's seeing in your network. And then the other thing is that wouldn't you like to, every morning when you come in, know the network is running well? So we can generate synthetic traffic. We can set a key performance indicator, a KPI, and every morning at 6 a.m. the network self-tests itself and generates this data and tells you if anything is outside of the benchmark. And this is a machine learning algorithm as well, so this can change over time as well. And I've already mentioned this here, but we also have 2 weeks of data, and it will be more as time goes on. But all that metadata, we can go back in 2 weeks in time and completely recreate that session that was happening at the time someone was complaining about a problem. So they say, a week ago, the wireless really stunk when I was in this building. We can actually go back to that time, see how they were moving through the network, see what devices they were hitting, and as Rob will show you, see if they were hitting ACLs or something that could have been causing a problem there. So we can go back in time. The idea behind it is, eventually you'll make changes to the network too, and we will actually see if the network has gotten better over it. We can do this on both the wired and the wireless side. We have a new line of sensors on the wireless side that you can use just to plug into a room if you've been having problematic wireless. It will act as a client and send information back up through the network. And our APs can flip into that mode as well to be able to send that information up into the network. So the idea is to make troubleshooting easier in this. Now, one of the partnerships that we have that is going to make things better, we hope, is our partnership with Apple. And the Apple partnership came about because Apple had a lot of problems with their Wi-Fi early on, right? These devices were absolutely great consumer devices, but they didn't play well when they got into our environment. So we developed that partnership with Apple. We realized we have an opportunity to drive changes into the way clients work through this relationship. Trying to get all the Android and Windows and everyone to play along, that's a pretty difficult problem. But getting one company to play with this is something that we can do. So we've incorporated the ability to collect stats out of Apple devices so you can actually see how they're operating on your network. And the neat thing about it is these Apple devices are now sensors that are running through your network and sending data up to DNA Center that you can actually use. So every time an Apple device walks into a room, it will tell us how it sees the wireless network. You used to send a person out, with a sniffer device to be able to do this, right? An Apple device will tell me all the APs it sees at what signal strengths, and it will correlate that to a map. Every time an Apple device roams to a different AP because it ran into interference or it ran into a coverage hole, it will actually tell us that information, and it will be correlated, context once again, it'll be correlated to where they were in the network when that happened. And we will see the reason for that roam that came up. And what you'll do is it will develop maps of where your wireless coverage is good and where your wireless coverage needs some kind of attention, and this is something that you can actually act on. Lastly, on the Apple side, we have the ability to prioritize different apps on those. Jeremy mentioned quality of service or so on. We can give quality of service by app, and with our SMS, our system from Meraki, you can actually, when someone loads an app on there, certain quality of service parameters can get tied to that app as well. So you can prioritize those things within your business. So I mentioned the wireless. I'm going to jump ahead real quick. This is what the non-Meraki wireless looks like. What's driving the industry right now is Wave 2 is out, right? And a lot of people, when they buy wireless for their home, they get enamored with these crazy speeds. Well, we don't really want these crazy speeds, in our environments for the most part. What we really want in the enterprise is we want really, really good channel reuse. So the whole industry doesn't really take advantage of these crazy speeds out there. So what we did when we developed our Wave 2 is we said, look, one of the biggest problems we see with our customers is they have too much 2.4 in their environment. Anyone running into that? Anyone shutting down 2.4 radios because there's too much of the contention in it? Well, that's a waste of a radio. So what we allow you to do is we have something called flexible radio assignment that we can reuse that radio in a different manner. So it could be a sensor generating that traffic that I talked about. It can be just a monitor that's listening in your environment for bad things happening. Or it can be another 5 gigahertz radio. So we can give you 2 APs in one AP. And the reason why we want to do that is there are so many more channels on the 5 gigahertz side than on the 2.4. 2.4 is really going away. It's kind of the sewer of Wi-Fi now. When we do events, we see connection rates for things like the Super Bowl or so on in excess of 80% onto the 5 gigahertz side. These devices are being designed to prefer the 5 gigahertz side, mostly because it uses less battery power if it does that, right? So an Apple engineer, my choice is make it prefer 11 AC or put a bigger battery in. What are they going to do? They make it prefer 11 AC. So what you get out of it is you can get 2 cells out of one individual AP. And Rob, I think we'll talk about this, but we can dynamically allocate this too. We can have the AP decide when you need 2.4 in an area or when you need more 5 gigahertz. In the AP line, it's kind of a standard AP line. This is the non-Meraki line. All the way down from the 1000 series are our commodity chipsets, meaning this is the same chipset that all our competitors use. And then what we do is we innovate on our 2800 and our 3800 series, and that gets you things like that flexible radio assignment. I mentioned this already as well, the little sensor device that can plug into your network if you want to be constantly testing your Wi-Fi. They don't show a good picture of it here, but one of them, it just has an AC plug on it. It just actually just goes and plugs into the AC outlet, and you can actually put a test device in a room. That's very critical that you're always assuring that it has really good wireless connectivity. And then lastly, just the outdoor APs as well. We do a lot of design work with these. Last thing I'm going to mention is 11AX, because you're going to start hearing about this soon. We've had some competitors actually pre-announce. The reality is that competitor, the chipset for that competitor, we're their biggest customer, so we know exactly what's going on in 11AX, and we'll have AX products out next year, most probably. But the one thing about 11AX, I call it token ring for wireless. What it really has, you know, of course they're going to scream about super fast speeds. We don't care about that. What we care about is a better scheduling mechanism in really, really dense environments.